Hi, this is Julia Walker with Grey Duck Forge, and today we're going to be talking about the cushions of the hoof to wrap up the Hoof Structures Series. After today, we will have discussed in detail every hoof structure you can reasonably expect to be involved in a certification-style exam, as far as I know. It's probably been more structures than you thought there would be, but what can I say? I'm thorough. So, without further ado, jumping into things and this whole cushions business, let's clear the air. What exactly is a cushion? Well, I'm glad you asked. It depends. Cushions, as they're called, tend to be a weird mix of fibrous, fatty, and cartilaginous material, all held together in a biological lump. It's a loose description, but it's also a description I'm comfortable making, so let's run with it. Cushions absorb concussion, improve circulation, and connect stuff. They tend not to get a lot of blood supply themselves, but help move the blood around for everyone else. Selfless, I know. But because of their self-sacrifice, if you ever get infection into a cushion or cartilage, things can get awfully dicey awfully fast. As farriers, we try to stay away from the internal structures, obviously, but sometimes things like quitter can come into play. There are other structures in the hoof that aren't called cushions, but still provide some cushioning, so we'll talk about those too. So, let's crack on then. So the main cushions in the hoof are the digital cushion, sometimes called the plantar cushion, the collateral cartilages, and the coronary cushion. So let's start with the digital cushion. It does all the cushiony things, like absorbing concussion and pumping blood, and it also helps make the back part of the foot flexible. In contrast, the front half of the foot is more rigid due to the firm connection to the coffin bone. But use it or lose it, the front feet bear more weight and so need more cushioning. It's a generally known trend that front feet correspondingly then have bigger digital cushions than hind feet. And think about that too. The center of mass of a horse is just behind where a girth sits by their heart. So does knowing that help explain why the cushions of the front feet would need to be more robust than a structure on the back part of a hind foot? You know, if you've got a horse that's over here and we're doing a kindergarten drawing of a horse, but say there's your horse and their center of mass is here, and then they've got a big old hoof so that we can kind of see what's going on both of these sides. Center mass is here. You know, there's a lot of weight kind of in the back part of that front foot, whereas on the back part of that back foot, I mean, all the weight is like way in front of it. So this probably doesn't need to be as robust. The digital cushion also helps hold the collateral cartilages apart, especially when the leg is loaded. It basically acts like a spring between the cartilages and pushes them outwards. There's a diagram in our textbook that kind of shows the cartilages on either side of the hoof, and then the digital cushion in between them, and it's kind of drawn like, oh, yeah. When the foot gets compressed, this is pushing outwards against those collateral cartilages. Cool, right? You can find the digital cushion also between the navicular bone and the frog. So, under the navicular bone, but on top of the frog. So this diagram is fantastic from Gregory's textbook of farriery, and if you screenshot it now and label it yourself, then there's a study tool for you. You can find the answers in Gregory's book, and if you don't already have it, go get yourself one. Number 16 here is the digital cushion, pointing to this yellow blobby mass, and everything else is there for your reference. You can see that the digital cushion is tucked back behind the coria, so like your sole corium, your sensitive sole, and then it's specifically under your frog corium. But if you were looking at like a dissected foot, and this was sort of what you had, then it would be part of like the foot itself and not the hoof. And it would be like under the skin. So you can palpate the digital cushion as well on a horse in general, just by stuffing your finger in here and just squishing away. So if you had to guess, which foot here would be the front foot? Yep, you guessed. Maybe you guessed it, but it's the one on the right. So this would be a front. Whereas you could expect a shape like this to be more hindy, for the most part. So if you have a horse owner that asks if their horse has a nice digital cushion or not, which doesn't happen that often, but sometimes, Make sure you're noticing if it's a front or a hind leg, and explain to them the difference between the two. It'll give you lots to talk about anyway. But moving on then, since I mentioned it a couple slides ago, let's talk collateral cartilages. They're super useful structures, and they do expand outwards while doing cushiony things. They are also bigger on front feet than hinds, kind of like your digital cushion, but that's more of a general trend, and specific horses might have unusually large or small collateral cartilages. They're also located only partially inside the hoof, and the tops of them can be palpated up in that coronary region on either side of the foot. But they are attached to the wings of the coffin bone, called the palmar processes, by several ligaments that I describe in that tendons and ligaments of the hoof video. You can go check that out if you need to see which ligament is which, but there's sort of those chrondo, coronal, ungular, tendinous, competal, all of those ligaments. And when it comes to problems with these bad boys, these collateral cartilages, the most common one that we as farriers see is when they turn to bone or ossify, resulting in that side bone. This especially becomes a problem if the ossified cartilage breaks, because it causes acute lameness until the cartilage heals itself, usually with even more bone. It's a bad cycle. The collateral cartilages can also get infected, which is called quitter, and is a super bad diagnosis for a horse. There is a lot of circulation around the outside of the cartilages, but blood doesn't really go into them, so there aren't any white blood cells inside to kill off infection. Treatment is usually something like local diffusions of drugs and sometimes scraping away the dead, aka necrotic tissue. But the odds of a horse making an awesome recovery are pretty low. It presents similarly to an abscess, which is why farriers might be involved. Like the horse is kind of non-weight bearing on that leg, whatever, and there's pus draining from the hoof area, so, right, abscess, you might think. But it's not draining from the hoof itself, it'd be draining from up by the collateral cartilages, like from the leg. And so remember, if it isn't in the hoof, we get to tell the owner to call the vet. So super fun. It's a yucky problem. And this is coming from that Anatomy of the Equine page. They have a lot of really cool photograph materials as well. So you can also go check them out for some other stuff. It's not certification type stuff, but it's still really good info that they have. And these are both a couple pictures that they had with a couple different size collateral cartilages. And even looking at like the feet on the left side, like you can kind of tell that the one on the left has something a little more robust happening than the horse on the right in terms of cartilages specifically, or, like relative to the size of the foot, like it just looks like there's a lot more cartilage on the left than there is on the right. So it's just kind of pretty interesting, very much case by case basis, like a really flat footed pancakey type foot on the right versus something that's less that way. Just kind of interesting. And here we have some broken side bones. This is not what you want to see on an x-ray. So these like creeping up bones on the sides here are going to be that side bone stuff. And then obviously like with a break in the middle, that's bad. And they're the cartilages that are ossified. And with both of them broken, I'd expect that horse to be really lame. So there you go. And then kind of lastly, in terms of like the quote unquote cushions, we're talking the coronary cushion. So every farrier has prodded a coronary cushion or two in their day, and it's pretty important. It's the structure that the coronary corium is built off of, so it determines basically the hoof wall thickness based off of its dimensions. So the coronary corium is thicker at the toe than at the quarters, just like the hoof wall. And then at the back of the foot, it merges with the digital cushion / the heel bulbs, and it attaches to the main extensor tendon up by the extensor process of P3, which is kind of interesting. And it also attaches to the collateral cartilages, all this according to Butler's textbook. It's made out of the same material as the digital cushion, and it does cushion things. To be specific, it reduces concussion and helps pump blood. It also helps form that flexible connection between the wall and the coffin bone, so that's pretty cool. So, pop quiz. Which is which? I'll give you a second to soak in this very dotted, slightly confusing picture, but it's a diagram out of Butler's P3, and it's another that's another absolute essential of a textbook for anyone shooting a certification. Just note that between A and C, one is up higher than the other, which should be your main clue on which is which. So, if you figured it out, either way, I'm going to give you the answers. A are those collateral cartilages. B, it's going to be your coronary cushion. And C is going to be your digital cushion or plantar cushion. Awesome. So do other things provide cushioning in the hoof? Oh yeah, here's 4, and it's possible that there are more. None of these are like the quote-unquote cushions. They're not called that, but the job of the navicular bursa, for example, is essentially to cushion the force of the DDFT on the navicular bone. The articular cartilage cushions the places where the bones touch in the coffin joint. So instead of the bones like knocking together and breaking, instead they've got nice cushy bumpers to bump into each other softly a little bit more. And the synovial fluid keeps everything in the joint soft, and kind of under force does some hydraulic cushioning. And blood also in all the different vessels is like a hydraulic cushion whenever the foot is compressed. Kind of like a water bed is sort of like the image that comes to mind for me. So yeah, there's a whole lot of cushioning going on in your average horse's hoof. So in review, the coronary cushion determines the shape, size, and thickness of the hoof wall in a lot of important ways. It's just what grows off of it that actually does that job. The collateral cartilages are partially only halfway in the hoof, but they help keep the back part of the hoof flexible by expanding outwards when the hoof is compressed. The digital cushion works with the collateral cartilages to absorb concussion in the foot and keep the back half of the hoof nice and squishy, plus all the circulation stuff that it does. And lastly, cushions tend not to have a lot of blood flow, leaving them prone to infection, and in the more cartilaginous structures, ossification as well. And with that, we are done with the Hoof Structures series. Way cool. So if you want a more condensed review video with some practice questions and answers, let me know in the comments, and if so, I can put one together for you. Otherwise, I am on to the next subject, which it looks like is going to be bones and joints. So we will be taking things one piece at a time, as always, and we're going to start with naming conventions in the first video of that series. As always, if you have any questions, comments, concerns, or corrections, toss them in the comments. Thank you for joining me on this ramble through hoof structures, and I am excited to continue on with the next section. So, as always, stay tuned for more.